So looking into our question paper of November 2024 exam. So this is our exam paper that we're going to look into as a full paper exam revision. So guys, we are simply going to go through our instructions. As we have our instructions, guys, make sure that you read everything, especially that your final answers, all final answers must be rounded off to 3 decimal places unless indicated differently, unless you are given certain information. So that is it, guys. That is it. Make sure that you read everything properly. So not gonna waste time, guys. Let us quickly go through our questions. On question number 1, which is the sketching of graphs, draw your graphs, this and that, 10 marks. So a given 1.1, it was to draw a neat graph of y is equal to 2e to the exponent of 3x. All right, so knowing, guys, your exponential functions, it was important as we are given y is equal to 2e to the exponent of 3x. That's a positive there that we have. So take note, it affects if you're given y is equal to a to the exponent of x. Okay, if you've got something of this nature, we are going to consider being positive, our x there being positive, and also the a that we have, like the coefficient of the number that is here affecting. So for a positive value and also for a positive value here, our sketch is supposed to be like this. Okay, that is when they are positive. If let's say we had a negative exponent there, we had a negative exponent, therefore it was going to be like this, tending to be approaching to what, to x. But let's say you do not know, guys, like the issue of how the graph is going to be, like at least know the exponential, how the functions, like the way your function is being drawn. All right, the way your functions are being drawn in case of when you are given this type of an exponential, we expect something of this nature as we are to draw our graphs. So at least if you have this idea, it can help you guys to say, you simply substitute even just a few values here. You just put in few values representing x. Let us just save a table like this, which can just show you how your graph is supposed to be like. Just few values. All right, let's just say when x is -2, we substitute in place of x when x is -1, when x is a 0, when x is 1, and so on and so on. So when x is -2, substituting here in place of x, that's y is equal to 2e to the exponent of 3 times what? -2 in place of x. That was going to give us something like 0.0049. When x is -1, if you substitute -1 there, it was going to give you something like 0.099, like that. This one was going to give you a 2. When x is 1, you're going to get 40.17. So just looking into these values, we can see, guys, it's like this. Guys, understanding your Cartesian plane is also important. That's why I was saying, if you just have a table like this, at least it can show you how the values are being taken. If you're to consider, let's say we've got -1, -2, this is 1, 2, and so on. We can see, guys, 0.049. This value is very, very small. 0.0, very, very small. These are the y values that we are having. So compared these values, guys, that we have, they are very, very small, close to the x-axis. They'll be very, very close to the x-axis, like maybe somewhere there, somewhere very close to the x-axis. So it's getting up. Then at 0 there, it corresponds with what? With 2. 0 corresponds with what? A 2, which is here. 1 and 40. It is going up 40, maybe somewhere there. Maybe that is where we have the 40 on top. So you see, guys, in terms of the positive, as we go to the positive, we are having an extreme increase in the y values. So understanding this alone, guys, can help you to have a sketch. So just know that your sketch or your graph was going to be like this. All right. So it will be tending to approach to the x-axis. It will be as if, guys, it's going to approach the x-axis like that. It will be approaching. As we can see, these values, they are approaching what? They are approaching 0. They are tending to approach to what? To 0 as they are decreasing. So that is the case of this graph on 1.21. Again, draw a neat graph of this. All right. So what are we given them? This is simply, guys, a linear function, a straight line. Y is equal to mx plus c. That's a straight line. So how can we obtain a linear function, a straight line? How can we draw a linear function, a straight line? Y is equal to what? Minus 2 over 3x minus 2. So as for the straight line, you just need the intercepts, guys. A linear function, remember, something like this, or it can be something like this, it can be something like this, it can be like this. So what you just need are the intercepts. So with the intercepts, you are good to have what? Your straight line. So the intercepts, we're going to have the x-intercept, which is on a condition where y is equal to 0. Remember your conditions for the x-intercept to occur, y is supposed to be 0. So in place of y here, we are going to substitute as 0. Then we solve for x. So this is minus 2 over 3x minus 2. So to solve for x, it's either going to take this to the other side, it becomes a positive, or you can take the minus 2 to the other side. It is up to you guys. So as for me, I'm going to take this part of x to the other side. So it was going to be positive 2 over 3x, which is equal to minus 2. The minus 2 there is remaining with a negative 2 over 3. This is just a number, guys. If you're given 2x is equal to 4, how do you find x? You simply divide by what? By 2. So even if you're given 2 over 3x is equal, this is just a number like 2 over 3. You can even divide by that number. Simply divide by it. Divide by 2 over 3 here. Divide by 2 over 3 here. Cancel this. Your calculator, guys. That's why you have the calculator in exam. It is the job or it is the duty of a calculator, guys, to simplify these fractions. With your calculator, you can simplify these fractions. So let us just have this part here. So we're going to have, that's negative 2. You put a fraction, that's 2 over 3. Just open a bracket there, 2 over a 3 like this. All right, so this is what we're going to have, negative 3. So x was going to give us what? Negative 3 as our as our x-intercept. On the same conditions, we are going to, just like this part now, we are going to determine the y-intercept, which is on a condition. Take note, you are talking about y there, but what is that you substitute? It is x that you substitute, which is equal to 0. So in place of x, we are going to put the 0 there. So meaning to say y is equal to minus 2 over 3 times 0 minus 2. That's y is equal to what? Minus 2. So just use your calculator. So this is enough, guys. Having these intercepts, our graph can be drawn from the intercepts that we are having, which is our x-intercept and the y-intercept that we are having. So it is very, very important that whenever you are to draw a graph, you consider that. Whenever you are to draw a straight line, you are to consider the intercepts. It's all about the intercepts, guys. So just, okay, this is too much. Let me just continue the way I was having. Let me just continue with this, guys. I'm just gonna sketch, guys. You're gonna have the actual thing. But here, let's just show you guys how you're going to have your answers. So that is it, guys. For the x-axis, we need minus 3. That's 0, 1, 2, and so on. Minus 1, minus 2, minus 3, minus 4. The y we need minus 2. Up to minus 2, it's enough. All right. So that is it. When x is what? For the x-intercept, we have got minus 3 in the x-axis. X-intercept means it lies what? In the x-axis. So minus 3. All right. The y value, minus 2. That was our condition there. Just like that. So with these guys, we can actually have our line drawn. That is just gonna mark, just gonna join these two, just like that. All right. So you guys, you can do something which is neater than this. So that is your straight line that you're going to have, and also the name. That's y is equal to minus 2 over 3x minus 2, just like that. So this is what we had. And you're being asked, is the graph y is equal to minus 2 over 3x minus 2 a function or a relation? Is this a function or a relation? So remember, it is easier for us to test for a function because we can use the vertical line test. So using the vertical line test, we were going to just consider a vertical line. As you can see, if you draw a vertical line, it meets the line at what? At one point. It is only at one point where these two meet, the vertical line and the line that we have drawn. They meet at what? Only one point. Like wherever you are going to have wherever you're going to have a vertical line, they will only meet at what? At one point. So that means we are dealing with what? A function. So this is a function. Just like that. All right. So guys, make sure that you do go through your revisions. Then 1.3, we are given draw the inverse of this. All right, x is equal to 1 over 5 ln y. All right, that is 1.5. Is it 1.5 or 1.3? This is 1.3, not 1.5. All right, x is equal to 1 over 5. The ln of y like this. Take note, the question is draw the what? Inverse. So on your memo there, it was actually a mistake, or it was actually an error there, because you are drawing the inverse. If you guys, I want you to note something here. If you are given a line, let's just talk of a line. Y is equal to x plus 1. It's a straight line, this one. All right. On this straight line that I'm having, it can be given with x as the subject of the formula. Guys, I can play around with this question and make x the subject. So it will be y minus 1 is equal to x. So I can decide to write it starting with x and say x is equal to y minus 1, like this. So my question is, what has changed between these two? What has changed? Nothing has changed. We just made x the subject, guys. It is still the same straight line that you're going to have. What, guys, look at these two lines here. Find the x-intercept of this. Find the x-intercept of this. You still have the same thing. Remember, the x-intercept is on a condition that y is 0. When y is 0, the x is what? X is minus 1. When y is 0, x is what? 1 to the other side. X is what? X is minus 1. Nothing has changed. Making the subject of the formula, like changing of the subject there to say, let me make x the subject, does not affect our function. So this is what I'm trying to say here. On this graph here, let's say we want to make y the subject. I'm not talking about the inverse. I'm just talking about the error of the question paper, your memo. If you make y the subject here, it is going to be what? Y is equal to, all right, actually, we have got this 5 here that is affecting. So we can maybe start with that one, multiply by it. So it was going to be 5x is equal to the ln of y. So remember, ln, we are in the base of e. So y is equal to e to the exponent of 5x. Guys, writing this And someone who is writing these two here, writing one of these two, it is just like you're playing around the same question. You're playing around the same line. You are making X the subject, you make Y the subject, and you think the line is going to change to look like this. No. Guys, take note, this is different when you have the inverse, when you interchange X and Y to say where X is, you're going to put Y, where Y is, you're going to put X, like this, to say X is equal to, in place of Y, you put X. In place of this X, you put Y like this, you write Y plus 1. Guys, these two graphs, they are totally different. They are totally different. These two, this one and this one. When you interchange the part of X and Y, it is a totally different graph. Not to make X the subject or to make Y the subject from what you're given, then you say the graphs, they have changed. It's like you're given Y is equal to X squared, right? Then you introduce the square root, then X is equal to square root of Y like that. Knowing that square root of any number is plus or minus, you haven't changed anything. The graph will be the same, whatever that you're going to have. You're going to have the same graph by making the subject. That's not the inverse. So that is the error that your question paper did. They drew this graph of Y is equal to e to the exponent of 5x, and they're saying this is the inverse. No, this is the same graph as this one. Put your values here, guys. Draw this graph and see it was going to be the same. This is the same graph of Y is equal to e to the exponent of 5x, which will be like this. This is the same graph there. Same, making the subject. That was a mistake. So the inverse, how do you find it? The inverse is the condition of an interchange, like what I did here on X and Y on this part that I was explaining here. Interchanging, you just interchange. Once you hear this part of inverse, guys, interchange. Where you see X, put Y. Interchange. Where you see X, you put Y. So that is going to be like this. Y is equal to 1 over 5, the ln of X. Where you see X, you put Y. Where you have Y, you put X. This is the inverse that we are going to have. So we are going to draw the graph of what? Y is equal to 1 over 5 ln X, this one. This is the one that we are going to have. Or if you wanted to have it as X as the subject, remember you interchange X and Y, then you make X the subject. It was going to be X is equal to e to the exponent. This will be 5y, so it's going to be e to the exponent of 5y if you make X the subject. These two, they're just the same. Like I said, making X the subject from what you are given does not affect your graph. Interchanging X and Y, that is the one that affects your graph to make inverse. So these two, guys, is the same thing. Just like here, what we had here, this graph here can be written as Y is equal to e to the exponent of what? E to the exponent of 5x. These two. It is the same graph, not to say it is its inverse. I hope you're together there. So no problem, guys. That is why we bring these memos. It's because of them. I mean, these revisions, because of some of the memos. Sometimes they, especially for maths, guys, I don't know. Maths and engineering science. And for, I don't know what is happening. But anyways, we'll see that. Remember the graph of a ln, guys, when we have X as 1, that is when our ln is what? That is when X is 1, we have what as 0 there. When X is 1, ln 1 is equal to 0. So meaning to say, we are going to have our graph. So X cannot be positive, guys. For a log cannot be negative, all right? So your graph was going to be like this, to be extending, increasing in the Y values. At this point, that is where X is 1. Remember, ln 1 is what? It's 0. The logarithm of a 1 is equal to what? To 0, as we do understand that in this x-axis, Y is equal to 0. So this is what you're going to have. This is the inverse. Y is equal to what? 1 over 5 ln of X, or you can write this one x is equal to what? E to the exponent of 5y. It's one and the same thing. So guys, you see this, you'll be having a question paper here, you have a memo there, then something sounds different. That is why we have to communicate. Let's communicate, guys. All right, so that we bring the revisions to clarity where there's a need. On question 2, we are given solve the value of x and y simultaneously using the complex numbers if given. This, all right, just for the sake of not making mistakes, guys, in rewriting, I'm just going to use this space here. Sorry for that. Let me just try. These are now adjustments, guys. We're just going to make some adjustments here so that you can see whatever that I'm going to write there. All right, so this is it. We are given this part of our complex. All right, that's 2.1. So as you can see, we've got brackets there, 3 plus 2j into, that's minus 6 plus j like this, is equal to x plus yj like this into minus 2 plus 4j like this. All right, so let us just expand our brackets here and see, guys, what's going to happen, because so far cannot say anything. So, all right, so far, guys, it's just complicated. It seems so 3 times negative 6, that's negative 18. 3 and this positive j, that's positive 3j. Remember, positive, positive. Okay, then we move on to the 2j here. So it's 2j times this negative 6. That's negative 12. So this is negative 12j. Positive 2 to the positive there. It was going to be positive again. So that's positive 2 j squared, right? Which is equal to, we do the same thing on the right-hand side, starting with the x. So that's x times minus 2, which is minus 2x. The x here and the 4j was going to be plus 4xj. All right, we're done with the x. Then we move on to the part of yj times negative 2. That was going to be negative 2y, then followed by what? A j like that. Then this part of yj and this, you multiply. That's positive, positive. So that was going to give us 4y there. So it was going to be positive 4yj squared. All right. Take note of the part where we have the j squared. This part where we have got the j squared. Every part where we have got the j squared there, we must be very, very careful. Since we do understand that j squared is equivalent to what? J squared is equal to minus 1. So wherever we have that, we are going to put a negative 1 there. So we are going to have a negative 1 here. We are going to have a negative there. All right, so let's simplify. Also, as we are simplifying, let us collect like terms at the same time. The 3j and the minus 12j, these are like terms where we have the j on its own, this part of the j. These are like terms. So on the left-hand side, simplify this. On the right-hand side, I'm going to talk about this because we also have the part of a j there. They are not numbers that we can simplify like the left-hand side, all right? So on the left-hand side, that's minus 18, 3 minus 12. These numbers can be simplified. 3 minus 12. So that's minus 9j. The j squared was going to give us minus 1, like I said, then minus 1 times 2, that's minus 2, is equal to, simplifying the left-hand side, you're going to have minus 2x. Take note, here we cannot simplify, like we cannot subtract like these two because of the algebraic terms that we are talking about. So what you can simply do is to factor out this j, which is common. So that was going to be plus. You open a bracket. As you can see, when you are writing, guys, you are starting with what? A number followed by a j. So just follow that part. So we are going to have the j outside of the bracket after, just like what we had here on this other part. You just maintain. If you want, you can even have it here. It's not a problem. I'm not saying it's wrong to have your j here. No. So you can factor out this j. positive 4x divided to this. The j and the j was going to cancel. This j and j was going to cancel. You remain with positive x, 4x minus 2yj, and this j was going to cancel. You remain with what? Negative 2y. Okay, so take note, you just remove this j out. The j squared on this part is negative 1, so negative times 4y, that's negative 4y like this. So this is what we have. And considering the left-hand side, we still have like terms there to consider, minus 18 and the minus 2. So we can collect these two, combining minus 18, minus 2, that's minus 20. So minus 20 minus 9j is equal to, so this is it. We are solving, remember, this is an equation that we need to formulate, or equations that we need to formulate. So as we see on the left-hand side, that we can properly see the real part on its own, and also the part of the imaginary on its own, the part where we have the j here on its own. We are supposed to have the same thing, same layout. We are supposed to have the same layout from what? From the right-hand side. So if we check from the right-hand side, we have this part where the j is, this part here, where we have the j. This is the part of the imaginary, this here, if you consider this whole part here, where we have the j. It is part of what? The imaginary that we have. Where we do not have the j here on this part of minus 2x and this part of minus 2y. We do not have x there. So these are your real terms. You're going to take those ones as your real terms. So we are starting with the real term. So meaning to say we are going to start with the real terms, the minus 2x and the minus 4y. So this is it, minus 2x minus 4y like this. So you're considering just like as a real term here. So you're considering this just like as a single term. Yes, it's an expression, but now let's take it as a single term. Just going to put a bracket so that we see this is one thing. So on this other part, we've got what? Plus this part of a j. This is what? 4x minus 2y like this into what? Into j. Just like this, we've got a bracket showing that it's one thing that we have here. So you're going to notice that on this side, we have got the left-hand side, the real part, and imaginary. The right-hand side, the same thing, the real part and the imaginary. So we are going to equate the real terms, this part of the real terms together. We take this part, we equate it to what? To the real. The part of the imaginary, this part as it is, the part of the imaginary, we equate it together to what? To the imaginary. So we are going to formulate equations separate from here. So therefore we are saying what? The real part, minus 20, must be equal to this. So meaning to say, we are simply having minus 2x minus 4y is equal to what? Minus 20. You have formed an equation which you can even evaluate, reduce this equation in your way, guys. You can see that negative 2 is common, so you can even reduce by negative 2, by negative 2, by negative 2 like this. So x minus 4 divided by 2 was going to be positive 2y is equal to, that's a positive 10. So this is what we have. X plus 2y is equal to 10. Depending with the method that you're going to use, is it substitution or elimination, whatever that you're going to have at the end. If you're using substitution method, you can even make x the subject. It is up to you. But you have formed an equation from that statement. So you can just call this equation 1. We can even come back and make adjustments from there. With the same application, we are going to apply it on the j part, where we see the j. We have a j here, this part here. We have got a j. What is affecting that? It is what? Negative 9. So that coefficient as it is, must be equal to what we see on this other side, which is affecting j. What is the coefficient there? The bracket, it's a positive, this one. So positive does not affect. So it means 4x minus 2y as it was supposed to be like this, guys, the positive, but the positive does not affect. If there was a minus, we're going to consider that. So this whole part is equal to what? We have the part here of what? Negative 9. Where the j is. It's an equation. So this is equation 2. Can you reduce this? No, we cannot reduce this. So we can have our equation this way. This one, we can use any method. On the solving part now, is it by the elimination? Is it by it's up to you. Substitution, I mean elimination, you can see that 2y and this one was going to eliminate. So you can even use elimination. It was going to be easier. Substitution, again, you can even work with the substitution, make x the subject from here. It was going to be 10 minus 2y like this. You substitute this into what? Into x of this other equation. So substitute x is equal to what? 10 minus 2y into this equation in place of x. So we're going to have what? 4 into our x, 10 minus 2y, this one, minus 2y that we already have is equal to negative 9. So there we can solve for x. 4 times 10, that's 40. 4 times minus 2, that's minus 8y there. Minus 2y is equal to negative 9. Collect your like terms. That's 40. Minus 8 minus 2, that's negative 10y is equal to negative 9. Take the 40 to the other side or subtract 40. Both sides, that was going to give us what? Negative 10. So negative 10y is equal to negative 49. Divide by the negative 10 to have the value of what? The value of y there. So meaning to say y was going to be what? 49 over 10 or 4,9. So you can also have it as a decimal, 4,9. After finding this, you substitute where you made x the subject from that equation one that we had. Substitute there to find the value of x when y is equal to what? 49 over 10, or when y is 4,9. So that was going to be 10 minus 2 into the value of y, which is what? 49 over 10 or 4,9. So that was going to give us the value of x, which is 1 over 5, or as a decimal, it was going to be what? 0,2, just like that. So as we can see, guys, simple like that, we can apply the substitution method. But like I said, elimination method also was easier to apply because we can see that this part of x is the part of y there is the same. X plus 2y is equal to 10. Remember, x plus 2y is equal to 10. This is 4x minus 2y is equal to minus 9. So already the part of y there is the same. Positive 2, negative 2. What we just need is to eliminate. So what can we do, guys, to eliminate the part of y? Are we going to add or are we going to subtract? The signs are different, so we are going to add in order for us to eliminate. So that's whatever sign that you have used here must be used throughout. So we add 1 plus 4, which is 5. So that's 5x. This one cancels. 2y plus minus 2y cancels is equal to 10 plus minus 9, which is 1. 10 plus minus 9. So this was going to give us a 1. So simply divide by 5 by 5. You have the value of x. So that is it. Your x was going to be 1 over 5. So as you can see, guys, this is the same x that we have. So meaning to say, if we substitute this x back in any of these two equations, definitely we're going to have the same value of y that we got there. So different ways, guys, that you can use to solve your equations depending with what is easier for you. So you had to formulate the simultaneous equation from the complex number that we had, understanding the use of complex numbers, and also understanding from our complex equation that if we are given a number, let's say we are given x plus yj like this is equal to a plus bj like this, x must be equal to a, y must be equal to what? Y must be equal to b. You equate the real part on its own, you equate the imaginary part on its own, then form the equation. The equations that you form, guys, we do not know, are they simultaneous? Are you going to form a quadratic? Are you going to form linear equations? You form an equation from that statement, then solve whatever type of equation that you have formed there. All right, so that was it, guys. On 2.2, again, under our complex numbers, simplify. This is half pi over what? 3 pi over 12 times 2 pi over 12. So this is just to use our polar. Remember your polar form, guys. Under polar form, so it is just like this. You can convert even to degrees if you want. You can work with them as they are in pi, guys. What you just need to know is that for a multiplication, r angle theta, let's say one like this times r1 angle of theta. This is now 2 like this. For a product, remember, if you're multiplying these numbers in polar form, you multiply the magnitude, you add the angles, theta 1 plus what? Theta 2. You add your arguments, theta 1 and theta 2. For a division, what is that you do? Let's say we are given these two in polar form and they're under a division. The numbers, you divide them as they are on their own, r1 over r2. The angles, you subtract theta 1 minus theta 2. So meaning to say, applying these laws, guys, was going to be easier because here we're simply going to add the denominator there because these ones are under multiplication. So this one was going to be the angle as we are given. This is half pi over what? We add what is inside there because of what? Yes, just like we have a 1, guys, the number here is 1. We are not having the number, so we are not like given the number. The number is there, it's 1. So it is 1 times 1. Remember, you multiply R1 and R2. So 1 times 1, guys, is 1. But as for the angles, you are going to add. So it's either you can change these to degrees or you work with them as they are. So you add, this is 3 pi over 12 plus 2 pi over 12. You add. Remember, guys, this is the same denominator. Here we've got the same denominator, guys. So you simply add the numerators. So that was gonna be 3 plus 2, which is what? 5. So that's 5 over 12 pi. If the denominators are the same, just add the numerators. 3 plus 2, which is 5. We are at this stage. What are we having? A division. Under a division, how do you divide? You divide the numbers on their own, the angles you subtract. So you're going to divide 1 divided by 1, which is what? Which is 1. Then as for the angle now, you subtract the angles that we have inside there. So it's going to be 1 over 2 pi minus 5 over 12 pi like this. So on your calculator, guys, do not even waste your time. Just simplify this. 1 over 2 minus 5 over 12. 1 over 2 minus 5 over 12. So it was going to give us what? 1 over 12. So that's 1 over 12 pi. Just like that. So this is what you're going to have with that angle. Do not leave the angle. This is the indication that you have gotten. It's a format, the polar form. Remember the format of r cis theta like that. It's a polar form. So we have our r there as 1, then our angle is 1 over 12 pi, which you can even convert to degrees if you want. Remember, pi is equal to what? 180 degrees. So 180 divided by 12 was going to give us what? 15. So you can even have your answer is one angle of 15 degrees like that. One with an angle like that. So guys, these were your polar form application that you needed there. Go through your complex numbers, guys. I've talked about these introductions. So make sure you go through the introductions and also joining membership for more so that you can have more to that. 2.3, convert to polar form. If we are given this 7 minus 12j, how can we convert to polar form? Remember the polar form, it is in the form of r angle of theta like this, or r cis theta, which we need the resultant r and also the angle theta. So as for the resultant, you can simply look at it and calculate them. But as for the argument now, which is our angle theta, we actually need to know where exactly this is going to lie, in which quadrant, where we have the real being positive and the imaginary being a negative, if we were to present on the Argand diagram. All right, so on our Argand diagram, remember, this is your Argand diagram, this is our real, and this is our imaginary. The real is being positive, and the imaginary is being what? Is being negative. That is what we have here. The real being positive, imaginary, negative. So which side? Real, positive, imaginary, negative. So our part was going to be like this. We're going to have this here in this quadrant, in the fourth quadrant. That's where we have our real part here being what? Being positive. Then the imaginary here being what? A negative. So that is where we have our J12, minus J12, or minus 12J, this side. That is the case. So this will be your R, the one that you need. You can write this as small letter R. This is your theta, which is your argument. Theta, you can use this one, the acute angle, this one. Or you can use the actual angle. Remember the actual angle from the positive horizontal axis, from the positive horizontal axis. If you want to have it as a positive angle, you're going to move this way. This will be your positive angle. If you are moving this way, you take it what? As a negative angle, which is that reference angle that we are seeing. So this is the case. It's just like that. So what is our R there? Remember your Pythagoras theorem. So our R is equal to the square root of, if you are given in the form of A and B here, we're going to write square root of A squared plus B squared, or X squared plus, or you write imaginary squared plus, real X squared plus what? Imaginary squared, right? Just substitute numbers, guys. 7 squared plus minus 12 squared. So we need the number there that is affecting J, which is what? The negative 12, not the J. Do not include the J, is just showing us to say this is imaginary part. So that was going to give us 193 as a decimal. If you want, that was going to be 13.892. 13.892. We can have it like that, or you can leave it as the square root of 193. Then we determine our theta from the information that we have. This is opposite, remember. This is adjacent. So theta from arctan. So that's arctan opposite minus 12 over this. So if you want, you can put that or not. All right, 12 over 7. Opposite over adjacent. So that was going to be 59.744. Where our theta is, this is not like, actually, it is because I wrote theta here. I was supposed to write because I want to use this one. But if I wanted to use the actual angle, then I was going to call this one alpha, then the other one theta. Is naming of the angles, it's up to you. You can even call it theta. The other one is what? It's alpha. That is what is important. So here we are calculating just like as a reference angle, to say our reference angle, that is not including what? The negative. But in the actual sense of our theta, according to where we are in this region, remember I talked about this. This is anti. This is the clockwise, and the clockwise, our angles are supposed to be what? Negative. So therefore, our theta is supposed to be what? Negative 59.744. It is because of the direction. All right. Or if you wanted to see that you're going to put the negative 12 there. You will see that your theta was going to be negative. Remember, guys, your quadrants trigonometry concept. So with the negative 59.74 form, this is the reference angle here. We are simply working with the reference angle, this acute angle here that we see there. This is just the acute angle that we are seeing. But because of the direction, as we are now using the actual angle now, the minus 54, the minus 59.74, it is now the actual angle, but the direction, that is why. The same actual angle can be taken like this from here, like this here, this one. It is the same angle that we see there. But this one, it's a positive angle, the one that is in the anti-clockwise. So let's call it alpha. We can still have it 360 degrees minus this one, 59.744. Remember, angles at a point that up to 360. So that was going to give us 300.256 degrees. Guys, these two angles, they are the same. They are equal. They maintain same properties. For any part that you want, for anything that you want for these angles, they have the same properties. That is to show you that it is the same angle. So on your answer, you can use this acute angle or you can use this one. It is up to you. But remember, your polar form in the form of r theta, that means we're going to have, therefore, our answer as what? This part here was going to be 7 minus 12j. That question that we had, guys, I'm not going to rewrite it. Let me just write the answer, guys. So therefore, we're going to have the square root of 193. The angle you choose. Are you going to take this one or are you going to take this one? It is up to you. So you can use the negative 59.744 degrees, or you can use this one. It is up to you. That is it. Or you can also write this form in the form of r cis theta like this. This is your polar form, which we extend in the form of what? R cos theta plus j like this plus j sine theta. This is an expansion, guys. Polar form, yeah, we have it polar. This is the polar form, guys. It's fine like that. Having extending this, it's like you want to expand now. Where are you going? All right. So sometimes, guys, we just have some unnecessary stages in our mathematics. You see the memo putting some of the unnecessary stages. Then you think it's important. Well, it's not even important. So these guys who are doing these memos, guys, they're just like you guys. They can even ask a guy like you to say, okay, can you do a memo for us this term at a certain college? So I don't trust these things, guys. Just try to do more questions, guys. Do more questions. Also, as an individual, you must see that this is an error or not. And also communicate. Even if you see an error happening here on this platform, talk. That is, you're supposed to communicate. There's an error there and there. We talk about that. All right. So 2.4, determine the value of z, only z that we need there. It is only z, take note. So there we're just gonna use our determinants, all right? That is the part that you're gonna have. Let me just write this one aside. I do not want to have this, but let me just do it, guys. So 2.4, you were given 2x minus y plus z. Like this is equal to 4. Then x minus 2y plus 2z is equal to 6. This one was 3x plus y plus z, which is equal to 8. So that's it, guys. And they said we must calculate z only here that they mentioned using our determinants. So how can we find our z, guys, from our determinants? Cramer's rule, guys, applying. That z can be determined if we calculate the determinant corresponding to z over the determinant of what? Constants, which you can write with a 0 there to show that we are using what? Constants, or just leave like that. So what is the determinant, guys, of or with respect to z when we are working with the z? We must close where the z is substitute that with what? The constants. We substitute with the constants, all right? Remember your platform, guys. So that'll be, this is 1, yes, so it's 2, 1, 3. So that's 2, 1, 3, like this. That's a determinant. This is minus 1, minus 1, minus 2, 1. So this is minus 1, minus 2, and this is what? Positive 1. So in place where the z is, we are going to put what? The constants as they are. So that's 4, 6, 8, like this. We calculate our determinant. In the same manner, we are supposed to calculate the determinant from the constants. So from the constant sides, this is what we're going to have on our constants. These constants are not to be substituted. So what does it mean? We take this side as it is, the way that we see it. We take it as it is, all right? We do not have to include our constants. So we're going to take this is 2, 1, 3, minus 1, minus 2, 1. So that's minus 1, 2, that's minus 2 and 1. For z, here this is 1, this is 2, and this one, it's what? It's a 1, just like that. So you calculate your determinant, just like that. Remember, your determinants, guys, in this case, I'm going to expand from the first row here on top. I'm going to use this row here. So using those signs, remember plus, minus, plus, and so on and so on. So I'm going to take plus, minus, plus. The same thing I'm going to use here, guys, so that I do not, guys, you can use any row, any column. But for the sake of revision, guys, just do something easier. You're in exam. Don't try to be a champion in exam, guys. Just expand, guys, the way that you are used. You finish that exam, you're done. All right. Because under exam, guys, remember time also. So that is it. Remember our determinant. You're going to take the 2, all right, being affected with what? A positive. So that's positive 2, the determinant of, we close the row and the column where the 2 is. So if we close here, what are you remaining here? We take this as it is, what we see there as a 2 by 2 as it is. So we saw you're going to remain with minus 2, 6, 1, and 8. So we move on, minus 1 and a minus. Take note, there's a minus there. So it's minus, minus, which is what? A plus. So that was going to be plus 1. The determinant, if we close the row and the column where that minus 1 is, so you remain with 1, 6, 3, 8. All right. So that was the case that you're going to have 1, 6, 3, 8. 1, 6, 3, 8. The same thing 4 with a positive, the sign. It's positive. So that's positive 4. Its determinant, when you close the column and the row where the 4 is, this is what you're going to remain with 1, minus 2, 3, 1. All right. So that's 1, minus 2, 3, 1. We determine our determinant. Then we're going to move on to this one, guys, so that we do not have confusion. So remember, your determinant on a 2 by 2 like this, the product of the major diagonal, what is in the major, this one, the product of what is in this major diagonal minus what you see as a product in the what? In the minor diagonal. So this was going to be 2 into what? Multiply negative. So it was going to be like this, guys. Negative 2 times 8 minus 6 times 1, like this. Use your calculator to simplify that. It was going to give you negative 22. So let me just write the final answer, guys, there. It was going to give us what? Negative 22. We do the same thing on the positive 1. So that's positive 1 into, when I multiply again, major diagonal, 1 times 8 minus this 6 and what? 6 and 3. Minus 6 times 3, that was going to give us negative 10. 8 minus 18, that's negative 10. So this is 1 times negative 10 plus 4. We do the same thing on this part of a form. We're going to have the same, the answer, I mean, from the same concept, the major diagonal, that's 1 times 1 minus the minor diagonal, 2, negative 2 and what? -2 and 3. We combine this, it was going to give us a +7. 1 plus 6, which is what? A +7. Just like that. So combining everything, guys, that was going to give us the determinant of x, multiply everything, -44 minus 10 plus 28 was going to give us what? -26. All right, so we move on to the other part. You do the same, guys, just like how you calculated this. All right, just for the sake of my space here, guys, I'm just gonna remove this, but that is all you're supposed to make your calculations, guys. You calculate everything, you calculate this, and that, and that, and that, and that. You're done. So let's do the constant part. For the constant, this is what we have. And as we have this, just gonna put plus or minus, plus, I mean plus, minus, plus. So that was gonna be +2. Okay, that's +2. Determinant of, we close again the row where it is and also the column. So we're going to remain with -2, 2, 1, 1. All right, just like that. So it was going to be -2, 2, 1, 1 like this. We move on to the other part, the -1 and the minus there was going to give us what? A positive. So that's +1, determinant of what? We close where the -1 is on the row and also on the column. So you're gonna remain with 1, 2, 3, 1. So that's it. 1, 2, 3, 1. So it was gonna be 1, 2, 3, and this one. To the 1 with a sign, it's a positive. So that's +1. Its determinant by closing the row where it is and also the column. This is what you're going to remain with. 1, -2, 3, and 1. You are done. Just like the previous case, guys, you calculate your determinant. So that was going to give us the determinant or for the what? Constants. You can put the 0, guys, to just show that you are working with the constants, or just leave it like that. Guys, these are constants. No need to worry much there. All right, so let's substitute the values then. Simplify just like the previous case. It was going to be 2 into what? Product, just like the previous case, major minus the minor. So -2 times 1 minus the minor, which is what? 2 and 1 was going to give us a -4. So that's -4. So guys, I want you to do this throughout on your calculations. You simplify this one. So it's going to be +1 into 2 minus 3. So 2 minus 9. So it was going to be 2 here. 3 times 3 is what? 9. So that was going to give us -5. All right. That was gonna give us, this is 2, like 1, 3. Okay, guys. And I just, all right, it was 1. Okay, because I closed this one. This one. Guys, this is the 2, 3. I want to check here. Here, what were the numbers when I closed? When I closed this one, it was 1, 2, 1. This is what it was, a 2 here. Here it was a 2. Why am I getting the 3, guys? That was a 2, isn't it? This one, it was a 2. 1, 2, 3. Guys, how did I just mixed these ones? Here I just mixed my values, guys. I can see. And I just closed this part. That was supposed to be what? There was when we closed this -1 here. Remember the numbers that were here when we closed this -1 here. So it was supposed to be 1, 3. This one, 1, 3. And there was a 2 and a 1 here. I don't know. How did I mix here? It was 1, 3 here. I hope someone just saw this one and was like, okay, let me correct this one like this. Guys, the part of editing, guys, this issue of editing, it's gonna be something else. I'm just gonna correct here, guys. So it was supposed to be like this. All right, so let's correct this part, guys, together. So these are some of the mistakes that do happen on those guys of your department. They make mistakes. And you guys, you are like, as for them, they do not like find time now to check this mistake to say, okay, there's a mistake. So maybe they do. later on. But later on is it's something else. All right, so it's like this, guys. So that was it, guys. Remember here the numbers that we had, there was a 2 and a 1 here. There was a 2 and a 1. So when we closed here, so it was 1, 3, 2, 1. Okay, that was the case there, actually. All right. So meaning to say our determinant was gonna be what at the end? 1 and 1. So 1 times 1 is what? This one. So you're gonna multiply the 1 and 1. So that's the importance of also doing the preparations before you put into a recording. You can see, okay, this is on my preparations. I wrote something like this, but now my answer is like this. All right, so that was gonna be 1 minus 6, which is -5. All right, so that is where I was having my -5. I was having that answer, but now I was like, ow. All right, plus here 1 into, this is 1 minus, it's going to be 1 minus the product of this is what? -6. So it was going to be a 7 here. Okay, so that's it, guys. Using the major, 1 times 1, that's 1. -2 times 3, that's -6. So combining everything now, that was going to give us the determinant for our constants, which is -6. All right, so that's another error which we had on our memo there. I don't know how do they end up with the value that they had there, but that was an actual error. You're supposed to get a -6 there. So go through again, calculate in another way that you want, guys. Use another way. Remember, there we are using the first row that we are having there. This is the one that we're working with. But you can work with any part. You can work with any part there. So now on our formula, what is that we have? Our z determinant that corresponds to z over that one of the constants. So it was now a substitution. Remember, we got -26 there. So therefore, our z was gonna be negative 26 over what? Over -6. So that's it. Simplifying this, we are going to have a decimal +4,33 and so on and so on. So that's it. So guys, let's just try do many questions. It's important that you do recaps and revisions like this so that also as an individual, you can figure out where exactly you are before your exams. Question number 3, solve for x, all right? For the value of x in this equation from what? From 0 to 90. From 0 to 90, guys, it means your reference angle is your final answer. There's no adjustment that this one, I'm going to take it, is it this quadrant or what? So this one was a straightforward question if you are to consider. Remember, 1 over sine of x, it gives us what? The cosec of x. If it is 1 over the cos of x, it gives you the sec of x. So it is the opposite, guys. If we are given 1 over cosec, what gave us a cosec? If we put 1 over like this, it gives us a sine. So once we put 1 over a cosec, guys, 1 over cosec of x, it will give us what? A sine of x. The opposite to what you know. So you see now they want to play around with you. Mostly you're just given sine of x is equal to, or it's just sec of this is equal. It's direct. But once you have 1 over cosec, 1 over this, it changes to a sine. So it was going to be the sine of what? X minus 20. X minus 20 degrees is equal to 1 over sec, just like what we have 1 over cos giving us a sec. So the opposite, 1 over sec, will give us what? Will give us a cos. So that's cos 20 plus x, 20 degrees plus x. Just like that. So from 0 to 90 degrees, how do you solve this type of equations, guys? Our trigonometric of this nature. I said when you are given something like this, you can simply change either a cos to a sine. It is up to you. Are you going to change a sine to a cos or a cos to a sine? So in this case, I'm going to focus on the right-hand side. I'm going to change it to the left-hand side. So remember, a cos of x can be changed to a sine. It will be a sine of 90 degrees minus x. That's how we change a cos. It will be sine 90 minus x. So in our case, we want to change this one, cos this. So the left-hand side is not affected. Remember, my left-hand side is not affected. I want to change the right-hand side to look like the left-hand side. So my right-hand side, it was having a cos. A cos changes to a sine. It will be written as sine 90 minus x. So that's sine 90 degrees minus x represents the angle that we had here before. This is our angle, what we had before on the cos. What is it that we have here on our angle before? It's not x, it's 20 plus x. So you subtract that part as it is. 20 degrees plus what? Plus x. So we have converted, or we have changed a cos to a sine. All right. Remember, guys, your identities as we have your mathematics. It's all about identities. So from this, since a sine and a sine, we have a sine here and a sine. It's just like we're given a log of x and a log of 3. Showing that we've got the same base, we can cancel the log here and say x is equal to 3. Automatically, we can equate the x and the 3 as the same thing. If truly this is a sine and truly this is a sine, definitely what is being affected by those trig will be the same. This trig, it is affecting what? This angle. It means this angle under this trig must be equal to this angle under the same trig of a sine on the other side of the equation. There is no way. These two must be equal, provided that these two are the same, sine, sine. So if you wanted to change a sine to look like a cos, you're going to do the same thing. Then you equate. So here I changed a cos to a sine. So meaning to say I'm going to equate this. X minus 20 degrees is equal to what I have on the other side, which is 90 degrees minus 20 degrees plus x, which is a bracket. So we are now solving equations. These are just normal linear equations, guys, that we have expand brackets, collect like terms, this and that. So x minus 20 is equal to 90, distribute by a negative. This is negative 1 into the bracket. So that was going to be negative 1 times 20, which is negative 20. Negative 1 times x, which is what? Negative x. So on the left-hand side, there's nothing that we can do, but the right-hand side, we can simplify 90 minus 20. That's what? That's 70 minus x. So let's collect the terms of x to the one side, this one to the other side. Was going to be positive the moment it crosses the equal sign. So x plus x is equal to 70 degrees minus 20. That side was going to be a positive. So that's it. X plus x, 2x is equal to 90 degrees. So guys, simply divide by what? By 2. By 2, you are done. So therefore, our x was going to be what? 45 degrees at the end. So this is how our question was supposed to be like. They just wanted guys to test you guys there on the 1 over a sec, 1 over a cosec. If you know 1 over sine, therefore the opposite is true. So change to whatever that you want, guys. You can even play around with the other side. Can you do for the other side for the sake of revision so that we see, guys, if we are on the same page. Simplify as far as possible. It is just like those questions that you are given to prove. Only that there we do not have an answer. When you are being asked to prove, they will give you a certain answer to say, when you simplify, your answer is going to be like this. So only that. Only that. We do not have what? The answer. So we're supposed to simplify up to whatever that we are going to have, guys, at the end, like in our simplification, as we have our mathematical view. This is subtraction of fractions. Let's just subtract, guys. Remember your LCM of the given denominators. So I'm just going to take my denominators as they are, guys. 1 minus what? 1 minus the sine of x into 1 plus the sine of x. So I'm going to divide this and this. Was going to cancel. So I remain with the 1 plus sine x, which multiplies the numerator there. So it will be cos of x into 1 plus the sine of x. So take note, this one and this one canceled. So these are the two that you're multiplying. The same thing on this other side. This one and this one was going to cancel. So you multiply these two. Take note, there's a negative there. So it's negative cos of x into this one, 1 minus the sine of what? The sine of x. Just like that. So expanding, let's see what we're going to have, guys. As you can see, I've got brackets. So try to distribute first bracket by the cos, the second bracket by the minus cos of x. Let's see what we're going to have there. So that was going to be cos times 1. That's the cos of x, cos times sine. That was going to be positive cos of x, the sine of x, minus cos x times 1, that's minus cos of x, minus cos x and minus sine, that's plus. So that's plus cos of x, the sine of x like this. Everything over our denominator, 1 minus the sine of x into 1 plus the sine of x. Take note, we do not have an answer that we can try to consider to check if we are in the right direction. So in this case, let's just simplify and see, guys, wherever we have something common, ever we've got this that is common, simplify, collecting like terms. The cos minus cos was going to cancel. Then you've got like terms, cos of x and the cos of x. So we can add, this is 1 plus 1. So it was going to be 2 cos x sine of x. Everything over what? The denominator, which is 1 minus the sine of x into 1 plus the sine of x like this. Can we say we are in the simplest form? Yes, we can leave our answer because here we cannot even cancel. So we can even leave our answer at this stage because there's nothing that is common. But for those guys who wanted to extend further, this can be extended because we can see here that, all right, let's just take this one as it is. So it was going to remain as it is, 2 cos x sine x, 2 cos x, the sine of x over. This is a difference of 2 squares. 1 minus sine x into 1 plus sine x. That's a difference of 2 squares from what? 1 squared minus sine squared x. 1 squared, guys, we understand this is just what? This is just a 1 here. So it was just going to be a 1 like that. That's a difference of 2 squares. Which is the same as what? Remember your Pythagorean cos squared plus sine squared of x is equal to 1. So what made us to have this 1 minus sine squared? It was because we took it to the other side. So we left with what? Cos squared of x, which is 1 minus sine squared of x. So in place of this 1 minus sine squared of x, guys, we are going to put what? The equivalent, cos squared. So this was going to be written as 2 cos of x, the sine of x over what? That's cos squared of x. So this means there are 2 of them. So you can cancel the cos of x into these ones, which are 2. Going to remain with the cos of x. So at the end, this was going to give us 2 times sine over cos. Remember, sine over cos is what? Tan. So it's going to be 2 tan x in simplest form. This is the simplest form that you are supposed to have on this question. So guys, let's revise. It's mathematics. So even the one that will be creating the memo, guys, must be mathematically equipped. Not to say a name, to say you have a name, to say you are known to be teaching for 20 years, then you can create a memo. Some of them, guys, these mathematical skills, they need also practice. So age-wise, some of them, it will be something else. So that is why we end up with a lot of I'm worried about the lot of errors that we have in mathematics and especially engineering science. You'll be like, what is happening? Was this person? Okay, let's not talk about those people. Let's talk about our maths here. Prove that. Let's prove this, guys. Let's take our part here. I'm just gonna use any part here. Just gonna take the complicated left-hand side. All right, you can even prove from the right if you want. So I'm just going to work with the complicated part, the sine of 2x minus the sine of x, everything over the cos of 2x plus the cos of x is supposed to give us this one. So this is what we have on our left-hand side. We know the sine of 2x from our identities. Actually, from our identities, I wanted you to see something, guys. I forgot that I'm sharing my screen like this. Let me give you something here. Sorry for that. So we know that the sine of 2x is given as what? 2 sine x cos x. So I wanted you to see these identities, but the way that I'm sharing my screen, guys, you end up seeing my files inside of my files. So this is 2 sine of x cos of x, remember? All right. I'm gonna try. You see, I'm trying to open something. That's why it is doing like this. All right. There we are. There we are. There we are here. All right. So I want us to see here. All right. They gave us, is it N5? So it's in N5. So in N4, guys, you're not given. Sorry for that. You're only given this. All right. So only given this and also this part. All right. So that's for you to know the double angle. All right. So for the double angle, guys, you're supposed to know your double angle identities. There's no way. I thought that you're gonna have that one, guys. It's not yet updated. So if it is cos 2x, it can be cos squared of x minus the sine squared of x. It can be 2 cos squared x minus 1. It can be 1 minus 2 sine squared x. We are not given this, but for sine of 2x, it's just one identity. 2 sine of x, the cos of x, which is this one that we used. All right, so there is a minus sign of x here. So there we do not have an identity, just rewrite as it is. Okay, everything over what? So as of a cos, as we can see a cos, there are 3 identities for a cos, 3 for a cos 2x. 3 of them, which one can we take? And for which reason? Which one? Because already there is a cos here on the other part. It will be wise that we choose something that only has a cos. Not to say we take this one that has a cos and a sine, or we take this one that only has a sine. Where there is a cos like this, it's going to complicate our question, guys. So as you choose the identity, choose wisely. So this is the best that we can choose here because already here there's a cos. So we are going to choose this one, which is what? 2 cos squared of x minus 1. But already there's what? Plus cos of x there, which is what we have. So those were the identities in use. Then from there we can simplify. Okay, this is to prove, remember, sine. We need sine on top. So meaning to say we must get rid of the cos. We need cos in the denominator. So there's something about a factorization. If you properly see your answer, the guys, if you have that eye of mathematics, you can see that there's a factorization there. So let's factor out something which is common. Sine of x is common on top. So the sine of x into what? 2 sine x cos x, this one and this one was going to cancel. So you remain with what? 2 cos of x. This one and this one was going to cancel. You remain with what? -1. Everything over what? This part is to be factorized. As you can see, it's a quadratic. It is the same as we've got 2 cos squared x plus the cos of x minus 1. So guys, you do factorize. It's either you're going to introduce the k, let the cos of x be equal to k here, and we have this one as 2k squared plus k minus 1. You use your factorization, guys, as of factorization. You are not limited. There are so many ways. Factorize here. You're going to have what? 2 brackets that we are going to have as k plus 1. Another one is going to be 2k minus 1 after factorizing, where our k represents what? The cos. So it was going to be the cos of x plus 1. Another bracket is 2k minus 1. So it's going to be 2 cos of x minus 1. So guys, how to factorize? I have explained different ways from N3, even from those videos for grade 10. Go through, guys, check those factorizations because there are different ways. I explain this one, maybe you do not want it. I explain this one, maybe someone does not want it. So go through. But we're going to have these brackets, all of us, after we do factorize this one properly. All right. So as you can see, guys, that miracle that we're looking for is just occurred. This one and this one can cancel. So means I've got 1 and 1 here. So that's a sine of x times 1, which is the sine of x over the cos of x plus 1 times 1, which is the cos of x plus 1 as it is. Just as it is here from right-hand side. So this is exactly what we had on the right-hand side. So please, guys, just add more questions on the proof, the simplification of your trigonometric, this part of trigonometry, guys. Add as much as you can before your exams. So that was our 3.3 and 3.5. Simplify this. So here, guys, they just wanted you to simplify the left-hand side, the right-hand side. By the way, they asked there, tan 15. What is the answer to tan 15? Okay, let me do this thing of sharing this portion of the screen, guys. It is something else. Last time I ended up showing my files that I'm not supposed to show. This is what you're supposed to get. Tan 15 in its simplest form is what? 2 minus square root of 3. So they are saying if we are to simplify this, we are supposed to get 2 minus the square root of what? The square root of 3. 2 minus square root of 3. But we are not simplifying it as a tan the way that we are having it there, because we are not allowed to even use a calculator when it is like this. So we simplify from here, the right-hand side. So it's just like a proof that this is equal to tan 15, which is this one. So let's take our tan 15. So we said tan 15 is equal to, we are going to have the same answer, this one, but from here. All right. So tan 15 is equal to what? The sine, guys, this one we can properly see it. Let me not rewrite. The sine of 30. What is the equivalent? Sine of 30, this is 1 over 2. You can even use your calculator, guys. It's direct, or you can go back to the special angles. This is 60. This is 30. That's 1, 2, the square root of 3. So sine 30 opposite over hypotenuse. That's 1 over 2. Or you can just use your calculator, like I said, guys. Nothing much to worry about these special angles that you can say, because they are special angles. So if I use this one, it's going to be like this. Guys, no. Do not even worry about that. All right. So this is 1 plus the cos of 30. So the cos of 30 adjacent over hypotenuse. So that is the square root of 3 over what? 2 adjacent to 30. Or use your calculator, guys. Square root of 3 over 2 like this. So this is it. We want to simplify this so that it gives us this, because this is what we saw on our calculator. How is that possible, guys? How is this possible? All right, let's try to make something easier. 1 over 2, let's put it on its own, because this is a fraction. This is just like a fraction also. So I'm going to have my 1 over 2 like this, divided to this, meaning to say I have 1 plus the square root of 3 over 2 like this. So it is a single fraction on its own. This one, again, it's on its own like this. This is what I'm trying to say. So you consider this on its own. You consider this on its own. So if you are to consider that, it means here we can simplify, guys. Have it as a single fraction, just like the 1 over 2 that we are seeing here. Let us also have what? A single fraction here. 1, guys, 1 can be written in any denominator. If it is 3, it's 3 over 3. If it is 2, 1 is 2 over 2. So using the same denominators, we know that we can combine what? Our numerators together. So it is going to be 2 plus the square root of 3 there, as it is over what? 2. Remember, I said if the denominators are the same, just combine what? Just combine your numerators. We are used to this, guys. So this is where you are. Looking into this, we can say that there is a division, and from a division, we can introduce what? A multiplication. And we do understand that once we introduce a multiplication, we invert the second fraction. So it was going to be 2 over this 2 plus the square root of 3. So this can cancel the numerator to the denominator, okay? This numerator to this denominator. So that was going to give us what? At the end, we're going to have 1 times 1, which is 1 over 2 times, 1 times 2 plus the square root of 3. So that's 2 plus square root of 3. So this is where you are. This is not the simplest answer, guys, because we are under sets. We are dealing with the sets. We are working with the sets. Sets can tell us that we can what? Rationalize the denominator. Introduce the negative, multiply by the what? Negative there. So it's going to be 2 minus square root of 3, just like your complex numbers multiplying by the complex conjugate. It is the same thing. So you introduce a negative, you multiply both the numerator and what? The denominator. So that's 1 times this as it is. So it was going to be 2 minus square root of 3 over what? We are multiplying, guys. Remember from your complex, from your sets, that when you are dealing with a set of this nature, you see this is a difference of 2 squares. A minus B into A plus B. Even sets, they use that difference of 2 squares. This is what we have here. This bracket to this bracket. So what do we have? A minus B is going to give us what? A minus B into A plus B will give us A squared minus B squared. So it means we've got A squared, 2 squared, minus B squared, which is what? The square root of 3 squared. What is 2 squared? That's 4, minus the square root of 3 squared, which is what? Which is 3. So 4 minus 3, that's a 1. So as we can see, guys, the whole of this denominator was going to give us a 1 from the difference of 2 squares. And we understand that anything divided by 1 remains as it is. So it was going to be 2 minus the square root of 3. Exactly what we saw on our calculator, guys, on the tan 15. It gave us 2 minus square root of 3. It must give us the same thing from this simplification. Only that we are not using the calculator. We are applying the understanding of our sets. What we understand from our sets. Also that part of the trig that we understand from our special angles. And this simplification of the sets. All this is the simplification of what? Of sets. N3 mathematics. So they are trying to bring you back, guys, to the N3 stuff that you leave there just to say, okay, this one, let it go. I'm now in N4. I'm not going to do N3 stuff. They try to bring that information in as much they try. You see. Question 4.1, we are given here to determine the following limit as we are given an infinity. Guys, this is an infinity that we are seeing there. Meaning if we substitute, guys, this will be infinity over infinity. Infinity over infinity. How can you simplify that? Can you factorize? Guys, yes, you can try to factorize. Cube to the exponent of 3 is complicated. So what can we do? Remember, if we have a condition of an infinity over infinity or 0 over 0, try factorization, then reduce whatever that you can, or you can simply reduce each and every term that we have by dividing it. by the one that has got the highest exponent, the part of x. You focus with the x. Which x that has the highest exponent? Not to say the number, but only the x. Which x? It is x to the exponent of 3. So you divide everything by that. So it was going to be like this. The limit as x approaches to infinite like this, then you do everything. You divide, guys, by x cubed. This is the highest exponent. So it means we're going to have 2x cubed over what? Over x cubed minus x squared. Everything, guys, minus x squared over x cubed. 3x, 3x, this part of 3x plus 3x over what? Over x, each and every part. 9 over x cubed again, each and every part. You do the same thing for the what? For the denominator. In the denominator, we've got what? 5x cubed. So that's 5x to the exponent of 3 over x to the exponent of 3. The 3x again. This will be our 3x over x to the exponent of 3 minus 4 over x to the exponent of 3. Each and every part must be affected. This is part of your limits. So as we have this, as x is approaching to infinity, what are we going to have? This one, x cubed, the x cubed gonna cancel. You remain with a 2 there, minus x squared into x cubed. There are 2 here, here there are 3. So you're gonna have 1 in the denominator, 1x. So it was gonna be 1 over x. Here it is 1. Here there are 3. So if you cancel, we're gonna remain with what? 2 of them. So it's plus 3 over x squared. Okay? Plus, here there's nothing that we can do. 9 over x cubed. Everything over what? The same thing. This one and this one cancels. That's a 5. X into x cubed. We're going to remain with the 2 of them. So it was going to be plus 3 over x squared minus 4 over x cubed. Most of you, you do not want to see terms that are the same. Guys, mathematics is not about when you see the terms that are the same, I'm supposed to cancel. I'm supposed to cancel. No. No, 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 no. It is not supposed to be like that. It is not supposed to be like that. Okay, this was 3x. All right. Not 3x squared. I don't know. These guys, I don't know. They had a lot of errors this time. I don't know. It's like you see these guys, what they do. They take like a certain question paper, then they want to bring those adjustments from maybe question papers that were written long, long time ago. They try to bring new syllabus. They are trying to bring new things, new that. But in bringing those new things now, who is to do that part? No one. Like no one at all. So guys, that's the challenge. Anyways, guys, let's see. This is what we had. Here it was gonna be, we substitute the infinite now. Once you substitute, it means there is now an infinite everywhere. So you do not write limit here when you substitute. You were writing the limit before. Now you substitute. So it was going to be 2 minus 1 over infinity plus, guys, you just put infinity where you have x there. 2, 3 over infinity squared plus 9 over infinity cubed, everything like that. So it was going to be 5 plus 3 over, this was 3x, not 3x squared, according to what we see there. So it was going to be infinity squared minus 4 over what? The infinity cubed. Just substitute, guys, as you see here in place of x. So it follows that k over infinity approximates to a 0. Whether it is going to be infinity cubed here to the exponent of what, it will give you a 0, guys. K over infinite, a number over infinite. So all these where we have number over infinite are zeros that we see there. these are zeros. So it's just like a 0 here, a 0 here, a 0 here, just a 0 here, just like that. So it was going to give us what? 2 minus 0 minus 0, that's a 2. 5 plus 0 minus 0, that's what? That's a 5. Just like that. Easy like that. So that was it, guys. Try to figure out, add more to what we had. That was it there. Then with this part, you differentiate the following with respect to y. With respect to what? To y. So it is a derivative of x with respect to y that we need. Remember, I said this one, you differentiate each on its own. Each, guys, as you see it, y to the exponent of 3, remember, when it is of y like this, we expect to have it of a y to the exponent of n. So that if we have x in this format, the derivative of x with respect to y like this is going to be what? An y to the exponent of n minus 1, where you drop the exponent, subtract 1. So this is our case, y to the exponent of 3. So we're going to drop the exponent and subtract 1. So that's 3y squared. Okay. Then we move on to this one, 1 over e. Before we differentiate, is it possible? Is it in the format when given an exponential? An exponential, guys, let's save it the way that we are supposed to, like e to the exponent of not 1 over this, no. So how do we get rid of this 1 over? 1 over e to the exponent of negative 2. I remember 1 over, it's going to remove this negative. So it will be e to the exponent of what? 2y. Our exponents, guys, 1 over x to the exponent of minus n is x to the exponent of n. This is our n3. So this is what you're going to have there. Then we differentiate this. We can differentiate this. We are used to this. Remember e, when you differentiate e to the exponent of a number, e to the exponent of a number, guys, is just like the derivative of this one of ka to the exponent of f of x. I've talked about this, guys. When you differentiate this type, all right, we're dealing with f of x. Now it's f of y, guys. So it's ka to the exponent of f of y this time. So we know that the derivative of x with respect to y is going to be what? When it is like this, it will be k times the first derivative of that y that you have times a to the exponent of f of y like that times the ln of a. That is of a derivative of this nature. But guys, knowing you are dealing with the e, just know, guys, you drop this exponent, this the coefficient here of y. So it will be 2 e to the exponent of 2y. You're done. You're done if you know this. But if you want this formula or this format, then it's fine. In our case just a 1. So we're just dealing with 1. So we focus. What is the first derivative of y there? That's 2 times this one. It remains as it is. E to the exponent of what? F of y. E to the exponent of 2y times the ln of a, the ln of the base. We are dealing with the ln of e. What is the ln of e? The ln of e is 1. So if you multiply this, that's 2e to the exponent of 2y. So when you have e like this, guys, you're not supposed to even go through this part. Differentiate direct. As we know, when it is e to the exponent of 3x, we drop this number here, the one that is affecting x. So the derivative, it will be 3e to the exponent of 3. You just drop the coefficient of x. This one, there is nothing like we are supposed to subtract anything. No, the coefficient of x, it multiplies there. Then the part of x remains as it is. So in the same manner, even for this part of y here, we can differentiate. All right. So that is what we're going to have, guys. So we saw that we're going to drop this one. So it was going to be plus 2e to the exponent of 2x to the exponent of, this is 2y, sorry, this is to the exponent of 2y like that. You can even write the ln of e here, but we saw, guys, the ln of e is what? It's 1. So let's just remove it like that. All right, so we move on to the other part. Here we have got 1 over sec 2y. Remember, we talked about this where they try to confuse. We are used to 1 over a cos, giving us a sec. Now they give us 1 over a sec. So it's the opposite. 1 over a sec gives us what? A cos. So that's cos 2y. Then we differentiate. What is the derivative of a cos? Remember, cos changes to what? A sine. From our formula sheet, guys, cos changes to a sine. So that's negative 2. It changes to a sine. The sine of what? Sine of 2y. We differentiate each and every part, each part that you see. So we move on to the ln. When you differentiate ln, remember, if you're given ln of x, it's 1 over x. So ln, it's also 1 over that, but there's a negative 2. So it's negative 2 over what? Negative 2 over y. This one was going to give us negative 2 over y. Then we move on to the other part. 4 minus 4 pi times p. Are we having the letter y there? We do not have. So it is a constant. A derivative of a constant gives us what? Gives us a 0. Once you differentiate a constant, if you're not given that letter, it will give you a 0. So that was going to be plus 0 or minus 0, just up to you. That's a 0 there. Just like that. You differentiate each and every part. So this one is just 5 marks. They just mark like this. So you can show the stages aside of your derivatives. It's fine. It's up to you. All right. Another part, it was to differentiate y is equal to k ln kx using function of a function chain rule. Using the chain rule. All right. Let us go back to our formula sheet so that I show you guys some of these things. You have them. If you check here, on your derivatives, all right? So this is what we have from the product, the quotient, and also the application of what? An application of the chain rule, where dy dx is supposed to be equal to dy du times what? Du dx, this part, our chain rule. So this is what we need from our chain rule. So we are given y is equal to what? Ln kx, 4.3. Y is equal to k ln x. It's ln kx, sorry for that. So that's 4.3. So this is what you're given. And we need to apply function of a function. As we saw that, the derivative of y with respect to x must be taken from the derivative of y with respect to u times that of u with respect to x. Meaning to say, I must introduce a certain function to represent the u, which is not part of our equation. There's not there. So we need the u, which is not there. So we can let u to be equal to, what can we introduce u? Are we going to be saying ln of this whole part? No. We just choose the part that is affected in that ln inside this one, kx. So let u be equal to kx. So if u is equal to kx, therefore, what does it mean? Therefore, or thereafter, y will be equal to what? Y will be equal to the ln of what? This one, kx, take note. We introduced the u here. So it will be the ln of u there. In place of that what? In place of the kx, you put the u. So this is how you substitute, guys. You're introducing a function in place of another function. After, that is where you figure out what is the formula. The formula I need dy du. So where do I get this one? From here. I need what? Du dx. From where? From here. So we need to differentiate these. As we saw, we are going to need their derivatives. The derivative of u with respect to x, that's k. Remember, if it is 2x, We take the 2. If it is 3x, it's a linear, this one. So our answer was going to be K. On this other part, the derivative of y with respect to u, remember that's a ln. Just like the way we differentiate that ln is 1 over what you're differentiating, 1 over u. So that's it. With respect to x, another one with respect to y. This is u with respect to x, y with respect to u. They are totally different. But we need these to differentiate this. So therefore, the derivative of y with respect to x was going to be what? dy du, dy du, this one, dy du here. That is 1 over u times du dx. This is our du dx, which is what? Which is k. So meaning to say, we have this k, guys, the same as what? K over 1. So it was supposed to be like k over u like this. But can we write our answer like k over u, guys? U, this one. It is something that we introduced. Let u be this. So we are going to introduce, we are going to take that back now. What represents the u? We said let it be what? Kx. So in place of that, substitute. So that will be k over u, which is what? Which is kx. So as we can see, we have a certain miracle happening here where the k and the k are the same. So they can cancel. So we are going to have our answer as 1 over what? 1 over x. So therefore, that is the derivative of y with respect to x. Our answer, carrying x. Carrying x, it was y with respect to x. So let our answer have x also. Just like what we had. Guys, did I share the screen? The one that I'm actually writing on. All right, this is exactly what I have. Because guys, see, working with a lot of things, you end up even not showing the screen. Then people, oh, you were writing from where? Where were you writing? We're not seeing what you're writing. Anyway, so this is it. That's our 4.3, just like that. Guys, mathematics is becoming easier now, and it is, guys, from what we have done, guys. If you are under this platform, as for mathematics, this is supposed to be a straight distinction. Under this platform, I don't know other platforms, but under this platform for mathematics, guys, we can talk of other subjects, not maths. Not maths, maths, guys. Quotient rule. So as we have our quotient rule, got e to the exponent of x over the sec of x, there 4.4. All right, so that's 4.4. Y is equal to, that was e to the exponent of x and a sec. E to the exponent of x, guys. Now I'm becoming old. I can't remember what I just read. This is over sec of x here. So as for mathematics, guys, like I was saying, failing mathematics under this platform, which maths is that one? Which level of maths is that one, guys, that you might fail? Let me know. Let me know. Like maybe if it happened, it was because you're not under this platform. Now that you're under this platform, that's what I'm saying. Now that you're under this platform, it cannot happen. All right. So when you're given this u, in this case, guys, I'm just gonna use v. This is u minus u. This is v over v squared. Simple, like that. Don't complicate these things. Yes, your formulas they are there. It's a formula that you're given, guys. That when y is equal to u over what? U over v. This is what you're going to have. So let us take our formula into consideration. That is what? Our quotient rule. Everything you are given, guys, even these derivatives thereafter, you are given in that formula sheet, some of them. Some, not all, some of them. So we saw that if y is equal to u over v, therefore its derivative of y with respect to x must be taken as what? That is v, sorry, the derivative of u minus u, the derivative of v over what? Over v squared. So according to us, what is representing our u, the one that is on top? That is our u, which is what? E to the exponent of x. What about its derivative? E, talking about this e, guys, it's just going to remain as it is because there's a 1 there. So if you drop this 1, it is just like 1e to the exponent of x. What have you done? Nothing. It is just e to the exponent of x. Okay. Then the sec of x representing what? The v. So the v is the sec of x. How do we differentiate sec? We have also this. Let me show you guys your derivatives so that we do not as if we are talking something which is from a sky that we do not know. If we check properly here, we are on the sec derivatives. Y with respect to x, the derivative of y with respect to x of a what? Of a sec will give us sec tan. So that's sec x tan x that we have there. All right, just like that. So you're gonna have sec tan like that. So this is sec of x, the tan of x. So this is it. With our formula, we're going to substitute. This is our formula, quotient rule. Remember, they said using the quotient rule. So they are saying if we are to use this formula, we're going to have V, which is our V is what? As it is the sec of x. So that's the sec of x into the derivative of u, which is the derivative u, is what? E to the exponent of x. Minus u, what is our u? As it was e to the exponent of x times the derivative of v. This is our v, which is the sec of x and tan of x. Everything over what? Everything over v squared, where v is the sec of x. So it means we are going to have that one as the sec of x squared. So that's sec of x squared like this. This is what you're given. Is there any other adjustment that we can do, guys? For this one, do not even waste your time. Even if you have it to waste, but do not waste your time, guys. It's exam. You have full marks there. Leave it like that. That's your quotient rule. Differentiate these, substitute into the formula. Simplification, we don't even care about it. Leave it like that. All right. 4.5 with the determine the coordinates of the point of inflection on this one with the aid of differentiation, the point of inflection, the second derivative there, second derivative of y with respect to x must be equal to 0. That is at the point of inflection, second derivative. So we must determine the second derivative, dy dx. What is dy dx from this? Y, which is x cubed minus 2x squared minus 8x. So we drop the exponent. So this was going to be 3x squared minus 2. And this was going to be minus 4x. This is minus 8x, guys. It's a constant. So you're going to get minus 8 as a constant because it's what? A linear. So this is the first derivative. When you equate this one to 0, guys, it's wrong. It's for the turning point. The first derivative to be equal to 0. It's for the turning point. We are not working with the turning point. This is the point of inflection. So we need the second derivative with respect to x again. So 2 times 3, that was going to be 6x. This was going to be minus 4. That's a constant, this one. So it's going to give us a 0. So this is what we have as your second derivative, and we are saying at the point of inflection, it must be equal to 0, this second derivative. So therefore, 6x minus 4 is equal to 0. Solve this. To the other side, the 4 was going to be positive. So divide by 6, guys, we're going to get the value of x, which is 2 over what? 2 over 3, just like that. So substituting, guys, into the original equation, as we do need this one as a what? As a point. It's a point. So we substitute the value of x into the y that we have there. That's 2 over 3 to the exponent of 3 minus 2 in place of x. That's 2 over 3 to the exponent of 2 minus 8 in place of x. That's 2 over 3 like this. So that is what we're going to have, guys. And with our calculator, we can simplify this part. All right, so let's just figure out what we're going to have. Open bracket 2 over 3 to the exponent of 3 minus 2. Okay, sorry, just move this one aside, guys. That's minus 2, open bracket, 2 over 3. 2 over 3 to the exponent of what? To the exponent of 2. Then we move, as I told aside this one, minus 8 into 2 over 3. This is 2 over what? 2 over 3, like this. So that was going to give us negative 160 over 27, or as a decimal, negative 5. You can even have it like this one, negative 5.926 to 3 decimal places, or we can have it as what? As this one that we saw here, negative 160 over 27, negative 160 over what? Over 27, this one. So that is our point of inflection can be what? Can be stated. So therefore, our point of inflection was going to be what? Our point of inflection was going to be given as x 2 over 3 and the value of y, which is what? Negative 160 over what? Over 27. Just like that. Or you can have it as a decimal. It's up to you. To 3 decimal places as you are given the instruction. Remember the question, the instruction was saying to 3 decimal places. So you maintain the instruction as you are given. Derivatives, so easy, guys, like that. Then looking into the integration, as long you understand your derivatives, guys, it means integration you are done, because it is just a reverse. And just like the previous question that we had, where we need to differentiate each and every part, we have it here, 5.1, where we need to integrate each and every part that we see. So in that case, make sure that everything is in the simplest form for you to be able to integrate. Make sure that everything is in simplest form. Can I integrate 2 sine x cos x? It's impossible. But we know from our identities, the one that I explained, the sine of what? The sine of 2x. It is equal to this. So instead, I'm going to work with the integral of the sine of 2x with respect to x. All right? So when you integrate a sine, remember, guys, from our concept of integration, it was a cos which we differentiated to give us a negative sign. So when we integrate a sine, it will give us negative cos. So that's negative cos of 2x over 2. Integration, you divide. Okay? 3 over sine squared. Can I integrate this? So it's difficult. But we know that over 1 over a sine, it's a cosec. One moment you have 1 over a sine, it will give what? A cosec. So what about if it is 3 over sine squared? It means this is 3 cosec squared x. 3 cosec squared x. We haven't integrated. I'm just saying, what does it mean? This one, the 3 over sine squared. It means 3 cosec squared. So if it means 3 cosec squared, guys, what is the integral now? That is the question of what? Of cosec squared, because we are used to those integrals. So we're going to go to our formula sheet. Let me show you this part so that we will be together. If you consider our formula sheet here, if we are dealing cosec, remember, we are on this side. So cosec squared, you oppose it. If you check the derivative of a cot, it's negative cosec squared. So when you have it as cosec squared as a positive, you must use the negative on what? On cot. The negative that you are seeing here must be taken to the what? To the cot. So that is the condition of what? So guys, know your integrals. And if you do not know how to play around with your formula sheet at the end, because that is the one that you have in your exam. So you saw that a cosec we changed to a negative cot. So that's negative 3. The cot of what? The cot of x. We move on to this one. Can we integrate an exponential the way that it is like that? Yes, an exponential can be integrated. Remember, on our derivatives, we have the derivative of an exponential like that. Also, on the integration of k a to the exponent of f of x with respect to x will give us what? Ka to the exponent of f of x like this over the first derivative with respect to x times the ln of a. Meaning to say, when we are working with this ln that we are, with this e, this is our k, 3. So it was going to be, we take the e as it is, e to the exponent of 3x over what? The first derivative, as we differentiate this 3x is 3 times the ln of a. Our a is what? A to the exponent of, which means our a is e. So that's the ln of e. So this can cancel, and we understand that the ln of e is what? It's 1. So as we see, guys, it was just going to remain as it is. It was just going to remain as it is. So here what made us to have this was because the 3, the constant, it was already there. Then we divided by this. So that is why we ended up with what? That was going to be e to the exponent of 3x, this one. E to the exponent of 3x. But knowing these guys integral, you don't even need to go through that. You know you're working with an exponential e. When you're working with an exponential, e to the exponent of 3x, you just divide. This time, you remember derivative, you were multiplying by this. Now it's integration. You divide by that exponent, this the coefficient of x, which is 3. So it was supposed to be like this. But because of the 3, which was already given, this one, the moment you multiply your answer here by 3, this one and this one was going to cancel. So you end up with this. So you can even use direct. If you want, the formulas are there also to assist you. Then on the other part, we've got pi to the exponent of 3. We do not have x there. Remember the integral of a constant. When we do not have x, we just what? Multiply by x. So that's pi to the exponent of 3 times x plus the constant of integration. Do not forget it's an integration that we are having. So we need the constant of integration at the end. So that was the case of our question. Pi, this one, it's pi to the exponent. It's as it is, not write as kx. The pi is the constant. Write what you have, guys, what you are given, not to say now it's a constant kx. Guys, I don't know the person that just did the memo for this time. It was just something else, but it happened. Let's see, 2.2, 5.2, evaluate the following definite integrals, substituting the limits. All right, so that's it, guys. As it is there, we're just gonna substitute our limits after integrating. So what are we integrating? A tan from our information sheet, guys. How do we integrate a tan? Do we have integral of a tan? That one we are already given from our formula sheet. We are already having that a tan, the integral of a tan gives us ln sec x, ln sec x. So this is what we have there. So we are going to have ln sec of x there. So that was simply going to give us the ln. So take note, is the tan, the 2 there, it is just a constant. So it's yes, so it will be 2 ln sec of x like this. Do not forget that the 2 here, it is just a product, can be taken outside. It's a constant that we have. So this is it. And our limits being taken from 0 to pi over 4. So 0 is our lower limit, pi over 4 as the upper limit, like that. So this is what we have. 2 ln sec x, 2 ln sec x. But we need to substitute. Can we substitute the ln, guys? I mean, the sec of x. It is difficult, but we know the sec of x, it's 1 over 1, the cos of x. So this is same as we have got 2 ln there. It is same as we have got 2 ln. Then this is 1 over, like this, 1 over the cos of x, so that we properly understand the meaning of what we have there. With our limits, pi over 4 and 0 there, we can substitute, starting with the lower limit. So remember the case, guys, lower limit minus the upper limit. You can even take out the 2 there, or you work with it as it is like this. So it's going to be 2, the ln of 1 over cos. We can even use the degrees there in place of pi over 4. If you work with the pi over 4 as it is, meaning to say your calculator must be in radians. Once you use this, your calculator must be in radians. Minus the lower limit, so it will be 2, the ln of 1 over cos what? 1 over cos 0, like this. With your calculator in radians. Your calculator is supposed to be in radians. If you want, or if you do not want to use the radians, simply convert here, because we know that pi over 4 is what? It's 180 divided by 4, which is what? 45. So that is what it means. Or you can simply use your calculator in what? In radians straight. So you change this, right? We need the mod, the radian. So there's no shift, just mod as it is. No shift, no shift. The rad, it's what? Number 4. All right. So the first one is 2. That's 2 ln 1 over, like that. 2 ln 1 over cos. So it's 2 ln. All right. Why is it dragging like this? I don't know. Is it network or what? This is 1 over cos pi over 4. This is pi over 4, like this. Pi over 4. All right, let's see what we can get on this one. This was going to be 0.693 on this one. It is giving us 0.693. Okay, that's going to be 0.693 minus the other one. When we have a 0 there, if you put a 0 here, all right, if we put a 0 like this, okay, the whole of this part is now a 0 like this. So that was going to give us a 0, guys. Okay, this whole part, 2 ln of this was going to give us a 0. So this is what we have. And with this part, that's going to be 0.693. All right, so this is 0.693 that we are going to have there at the end. So that is what we had there. All right, so you can simplify the part of your trig, this one, as it is, with the values that you have. 1 over cos this pi over 4, you can substitute those, guys, in your simplification, as long the presentation is exactly what you see here. We are going to have our final answers. Okay, so this is it. And the difference there was going to give us what? The same value, guys. Remember, you're subtracting a 0. It does not affect anything. All right, so that's our 5.2. Just like that, 5.3, given this, we are back now to the, all right, factorization, where we need application of your factorization before you integrate. So we have got 3x cubed minus 81 over what? 2x minus 6 with respect to x. So let's just try to factorize before we do the integration. All right. Do you have anything common here? We can factor out the 3. So it's gonna be 3 like this. So it'll be 3 into x cubed minus 81 divided by 3 is what? 27. So if you take, guys, x cubed minus 27, those are your algebraic, those identities those algebraic identities, guys, remember those a cubed from your N3, a cubed minus b cubed, all right, which is going to give us a minus b into the other bracket of a squared plus ab plus what, b squared. So expand, guys, using that application. You were going to have something like this 3, this one. So this other part was gonna, it will be like this, x cubed minus 3 cubed. So it will be a minus b, which is x minus 3, into a squared, which is x squared, plus ab plus x times 3, which is 3x plus b squared. Our b is 3. So 3 squared is what? Is 9. So this is what you're going to have. Everything over what? Here we can factor out the 2 in the denominator. So that's going to be 2x divided by 2, which is x, minus 6 divided by 2, which is minus 3, with respect to x. So that is it, guys. You can see that there's something common here. The numerator, denominator, we can factor out. We can divide what is common, this one and this one. The 3 over 2, you can even take it outside of the integral. It's a constant. So it's 3 over 2, the integral of this. So you must integrate everything that we have inside of the bracket. Everything that we are seeing with respect to x. So what we're going to have at the end, 3 over 2 into what? X squared. Remember, integration, you add the exponent, then you divide by the new exponent, over 3, plus we do the same thing, we add 1, so it's 1 plus 1, which is 2. So it's 3x squared over that 2. Okay, plus 9 is a constant, so you're going to multiply by what? By x. So it will be 9x plus the constant of integration. Expanding brackets is now your own, guys. You can leave it like that. You can expand these brackets, up to you. So if you expand the bracket, is 3 over 2 times x cubed over 3. So this was going to cancel. So it was going to be x cubed over 2. This one was going to 3 times 3, which is 9 over 2 times 2, which is 4, x squared. 3, this is same as 1. So it's 3 times 9, which is what? 27 over 2 times 1, which is 2. So it's 27 over 2x plus the constant of integration, like that. So this is what you're going to have at the end after expanding by what is outside of the bracket. Like I said, you can even decide to leave it like that. It is not of any effect. Sketch these 2 graphs, all right? Then definitely we know we're going to need what? We will need our application. These are now applications there. So there, guys, it was x is equal to 4y squared. It's a clear graph. If you do understand your functions, you'll see that we are just having, for every x value is being squared. Every x value, so it will give us what? A positive. Every x value, if you square a 1, a positive, a minus 1, positive. So we have same values of x, same values of y that will correspond, and also same values of x, same values of y that will correspond on the right-hand side, like this. It is symmetrical about the y-axis, this type of a graph, when you are given the graph of the form y is equal to ax squared, where a is positive, it's going to be like this. If it was a negative, it was going to be the other way. So this type of a graph, it is symmetrical to the y-axis, divided into 2. All right. So this is y is equal to 4x squared. And on the other hand, we have x is equal to 2y squared. Let's work it in terms of y so that we properly see which y are we talking about, because it's easier when we work with y. Let's make y the subject. X is equal to 2y squared divided by 2 by 2. So that's x over 2 is equal to y squared. Going to introduce the square root. So y is equal to the square root of x over 2. So what is the graph of x, the square root of x over 2? In this case, it must use both positive and negative values of y. Meaning to say, for each and every x value, y is going to be positive or negative. So our graph definitely is going to be like this. Y is going to be positive and negative for each and every value of x. So these two graphs, definitely, they do intersect at this point. Where they intersect, at what? At 0 and at this point. So we need that point, and also they are saying indicate the area as well as the strip. This is where we're going to calculate the area with respect to x, this and that. Within which limits? What are our limits? I mean, within which limits as the two graphs intersect? Where is it that the two graphs, they intersect? They intersect also. They do intersect at that point. So at that point of intersection, what is the value of y there? Remember, at the point of intersection, the two graphs are equal, guys. So what am I trying to say? The two graphs are equal. This one of y is equal to 4x squared is equal to this one of the square root of x over 2. So let's remove the square root. We're going to square this. We square this. So that's 4 squared 16x to the exponent of 4 is equal to, remember, to square is to remove this. So it's going to be x over 2. All right. So this is same as over 1. Cross multiply 2 times this was going to be 32. X to the exponent of 4 is equal to x. Let's take this to the other side. 32x to the exponent of 4 minus x is equal to 0. So x into 32 to the exponent of 3 minus 1 here is going to be equal to 0. So as we can see, the first one, we have it. The x, which is equal to what? The 0, this one. So x is equal to 0, or from this one, we equate it to 0. 32x to the exponent of 3 minus 1 is equal to 0. So you're going to take this 32 to the exponent of 3 is equal to 1. Divide by 32 by 32. So x cubed is equal to 1 over 32. So what will be the x? The cube root there. So x is the cube root of 1 over 132, so which is the cube root of this guy is 1 over 32. Was gonna give us 0, that was gonna be 0, 0.31498, something like that. So guys, you use that x there. So if you are using the 3 decimal place, it's 0.315. If you are using the 3 decimal place, you can take it like that, or you can just use the 0.31 decimal place, guys, for calculations. So this is what you need. You need this value. It is important here. So it passes at 0.315. I mean, that is the intersection here. So that part is important. 0.315 like that. So that is why you see it was 6 marks, guys. It's because of this. They know that some calculations in within for you to find the point of intersection of what the graphs. So that is what you have. So it's from 0 to 0.315. 5.52, then calculate the magnitude after that. Calculate the magnitude of what? The area included between the graphs with the aid of what? Integration. So you know that the area, the area is simply the difference that we're going to have from our integration. Our area is with respect to x. We are using the strip for x. So it is the difference that we have. Remember, we're going to calculate, that's the one that is on top, which is going to take this one. This is the one that is on top. So it's y1 minus y2. So that's going to be y1 minus y2 with respect to x, our limits being a and what? A and b. So y1 minus y2, y1 minus y2. You are dealing with what? The area. That is our case. We are dealing with what? The area. So we are going to take y1. Remember, y1 is the one, this one, which is on top, this one on top, y1. This one for the square root, this one. The square root of what? The square root of x over 2. Remember, square root means to the exponent of half. So it's x over 2 like this to the exponent of a half. Meaning to say, if you want to integrate, x will be raised to the exponent of a half. 2 is raised also to the exponent of a half. So it simply means, guys, this is x to the exponent of half over the square root of 2. The same thing that we see can be written like this. Because, guys, you see, inside you need to integrate. How are you going to integrate the square root? But if you have it in the way that you understand, you see? So this one, we're going to have y1 in a format that we can integrate x to the exponent of a half there over the square root of 2 minus y2. Y2 is the one that is below this graph, that is below this one, which is this one of 4x squared. On that region, which one is below, which one is on top? So the one that is below is this one of 4x squared. Already, y is the subject. Y is equal to what? 4x squared. So this one, we do not make any adjustments. So this is the integral of this with respect to x. Just like that. With our limits that we are given from where to where? From 0 to 0 0.35. From 0 to 0 0.315. These are our limits. So let's integrate, guys. Remember, integration, we add 1 on the exponent. So you're going to add 1. So it was supposed to be like this. X to the exponent of a half plus 1. So when we add, it's going to be what? 3 over 2. X to the exponent of 3 over 2 over. We divide by the new exponent, which is the 3 over 2. But remember, there's a square root of 2 that is there. So 1 over this, guys, 1 over this is 2 over 3. So it's just like we've got 2 over 3. So it will interchange to 2x to the exponent of 3 over 2 over 3 square root of 2. 1 over that can change that part. So this is the simplification that we are going to have if we are to simplify properly. Take note, guys. This is 3 over 2. Here it's 3 over 2. So it's 1 over 3 over 2. This one. 1 over this. What are you going to have? The 1 over 3 over 2 like this is going to give us what? 2 over 3. This one. It will give us what? 2 over 3. So the 2 is now on top. Not the 3, but the 2 is 1 that is on top. As you see now, if I see the person who did the memo for this time, I don't know what can I do, because there was a lot of errors, you see, guys, and that is not fair to in terms of revisions. So you must be careful. It's a division. Use your calculator. 1 divide to this. The number only this one. 1 divide to this. So it will give you 2. All right. So it's gonna be like this. We are now integrating. So it is now like this. 2x to the exponent of 3 over 2 over what? 3 square root of 2. All right, we do the same here. Add 1 there on the exponent. So it was going to be 4x to the exponent of 3. You add 1 over what? Over 3. So this one is direct, guys. 4x to the exponent of 3 over 3 like this. So with these limits, when you're given the limits, there is no need for you to write the constant of integration inside there. There is no need. If you're using the limits, just integrate, guys. Then apply your limits. This is 0.315, and that's a 0 there. So let's substitute our limits. Upper limit minus the lower limit. So our area with respect to x was going to be what? Upper limit in place of x, 2 into 0, 3, 1/5 to the exponent of 3 over 2 over what? 3 square root of 2 minus 4 in place of x, 0, 315 to the exponent of 3 over 3 like this. So this is the part of our upper limit. But as we can see, guys, the lower limit, you can see that's a 0 there, that's a 0 there. Do not even waste your time. It was just going to give you a 0 there. All right, so that is what you're going to have. Upper limit minus the lower limit. We simplify this, or we evaluate this properly on our calculator. That was going to give us what? Let's say for fraction here, 2 times 0 0.315. So this is 315 to the exponent of 3 over 2. All right, everything over 3 square root of 2. All right, then we move on to subtract this. So you're going to have minus a fraction again. 4 times 0, 315 to the exponent of what? To the exponent of 3. So that's to the exponent of 3, everything over what? Everything over 3 like this. So that was going to give us 0, 0.04, 2 to 3 decimal places. Let's shift setup 6, 3. So that's 0, 0.042. All right, so that's 0, 0.042 like that. This is area, and we do understand our area must be measured in what? In square units. So we can have this in square units. So let's try to work out, guys, as much questions as we can. Try to figure out how these questions might be given, as it is important as you are doing your revisions to work out as much questions. And also simplification, mathematical simplifications, they are also important. Knowing your formulas is not enough. Thereafter, the simplification, those small mathematical concepts, they are very, very important. So let's do revise in as much as we can. So that is what you're supposed to have, guys, for 100 marks in this mathematics N4 November 2024 exam. Till we meet again.